Hello everyone. In this video, we are going to see the numericals of the chapter fluids. Before we go to the numerical, let's go over some formulas which are there in this chapter. First one is pressure is thrust upon area. Now thrust is force which is acting perpendicular, so that will be measured in Newton, and area will be measured in meter squared. Okay, there are some conversions that you need to be careful about. So before we move to that, we'll see that pressure is measured in 1 Pascal, and this is 1 Newton upon 1 meter square. Okay, for conversions, what we have is 1 centimeter is 10 to the power minus 2 meter. 1 centimeter squared is 10 to the power minus 4 meter squared. And 1 centimeter cube will be 10 to the power minus 6 meter cube. In terms of millimeter, 1 millimeter is 10 to the power minus 3 meters. 1 millimeter squared will be 10 to the power minus 6 meter squared, and 1 millimeter cube will be 10 to the power minus 9 meter cube. Okay, so that is conversions that will be helpful. The next formula that we have is, if this is liquid and air, and if you are at a point A inside the liquid and the depth from the surface is h, then the pressure at point A is given by h rho g, where h stands for the depth from the surface, rho stands for density of liquid, and g stands for acceleration due to gravity. So this is the second formula. And now moving to the third one, which is based on Pascal's law. So if you have a confined liquid, usually the question gets asked based on these two cylinders, and there is a piston attached to both of them, and this is completely filled with a liquid. So according to Pascal's law, if force is applied on this, so let's call this as F1, and this piston has an area A1, then the pressure experienced will be experienced on the other piston as well, the same pressure. So this has area A2, and the force over here will be F2. So this will be F2 upon A2. So P1 will be equal to P2. So we have F1 upon A1 is equal to F2 upon A2. At times we can rearrange this as F1 upon F2 is A1 upon A2. So these are the three laws. Pressure is force upon area. Pressure at a point inside the liquid is equal to h rho g, where h is the depth from the surface, rho is the density of the liquid, and g is acceleration due to gravity. And according to Pascal's law, F1 upon A1 is equal to F2 upon A2. The assumption is that this is a confined liquid, a liquid that is restricted in this particular vessel. So now that we have discussed the formula, let's start with the numericals. In the first numerical, what we have, there is a hammer that is exerting a force of 1.5 Newton, and it is exerting that force on two nails which have area 2 millimeter squared, that is 2 into 10 to the power minus 6 meter squared. Another one has area of 6 millimeter squared, so that is 6 into 10 to the power minus 6 meter squared. So the pressure over here, which is force upon area, and that will be 1.5, and that will be 2 into 10 to the power minus 6. So that will be 0.75 and 10 to the power 6. So pressure will be 7.5 into 10 to the power 5 Pascal. So that will be the pressure. For the other one, pressure which is force upon area, and here you have 6, here we have 1.5, 6 into 10 to the power minus 6, that will be 0.75 into 10 to the power 6, so that will be 7.5 into 10 to the power 5 Pascal. So this is the pressure that is experienced on the nail B, and this is the pressure that is experienced on nail E. Let's move to the next question. In the next question, we have an iron block. So this iron block, the dimensions are given to us, and those dimensions are 12 centimeter, this is 8 centimeter, and this is 10 centimeter. The mass of the iron block, that means the weight will be mg, that is 7.5 into 10, that will be 75 Newton. Okay, so also remember this thing that when mass is 7.5 kg, weight is 7.5 kilogram force. Okay, now you want to express that kilogram force into Newton, you have to multiply by g, acceleration due to gravity. So this 7.5 Newton is acting downward, that's the weight, and that is acting on this area. So therefore, pressure, which is force upon area, will be 75 Newton divided by this area. Now this area is 12 into 8 into 10 to the power minus 4. Why? Because area, which is 12 into 8, that will be 96 centimeters square. So that will be 96 into 10 to the power minus 4 meters square. Okay. So this answer, if we reduce it, this will be 75, 12 into 8, and this will be 3 4s are and 3 25s are. So you are going to get 0.78125 into 10 to the power 4. So pressure can be written as 7.183 into 10 to the power 3 Pascal. Okay, you can even take this whole 1, 2, 3, 4, and you can write pressure as 7812.5 Pascal. That's also possible. Okay, let's move to the next question. So this vessel has water, and the height of water in the vessel is 1.5 meter. This area of the base is given to be 100 centimeters square. So what is the information given to us? Height is 1.5 meter, area is 100 centimeters squared. So that will be 100 into 10 to the power minus 4 meters squared. That will be 10 to the power minus 2 meters squared. Okay, so this is the area. They have given us density as 1000 kg per meter cube, that is density of water. So when they ask for pressure, there is no need for area. Pressure is H rho G. So this is 1.5 into 1000. Okay, so that will be 10 to the power 3, and the value of G to be taken as 9.8. So therefore, 1.5 into 9.8 will give you 14.7 into 10 to the power 3. So pressure is 1.47 into 10 to the power 4 Pascal. So this is the pressure. Now pressure is force upon area. So we have 1.47 into 10 to the power 4, and this is force, and area is 10 to the power minus 2. So we have 1.47 into 10 to the power 4. This is minus 2. So that will be 1.47 into 10 to the power 2, which gives you the force of 147 Newton. Okay, so the pressure is 1.47 into 10 to the power 4 Pascal, and force is 147 Newton. Let's move to the next. In question 4, we have the following information. So this is a cylindrical vessel. In the cylindrical vessel, water is up to the height of 6 centimeters. Okay, and this area is 300 centimeters square. Okay, so height is 6 centimeter, that is 6 into 10 to the power minus 2 meter. Area is 300 centimeters squared, that is 300 into 10 to the power minus 4. So that will be 3 into 10 to the power minus 2 meters squared. Okay, they are asking us to first calculate the pressure. Pressure again is H rho G. So therefore, this is 6 into 10 to the power minus 2. Density is 1000 of water, and G value is given to be 10. So minus 2 and 3, okay, will leave a 10, and 10 into 10 will be 100. So that will be 600 Pascal. So the pressure is 600 Pascal. Again, we have this formula, pressure as force over area. So therefore, force is pressure into area. So this is 600. This is 3 into 10 to the power minus 2. 10 to the power minus 2 will cancel these zeros, and you are left with 6 into 3. So force is 18 Newton. So the force exerted by this water on this area, which is underneath, is 18 Newton.